Hey everybody, welcome to Engineering Academy, and in this video I'll be talking about how to calculate the quantity of steel in a slab. Alright, so to demonstrate this, I'll be taking this panel as an example. So if you can calculate the quantity of steel in one panel, you can do the same thing for the rest of the panels, right? Alright, so before going into this tutorial, I would like to suggest you to watch a video on two-way slab reinforcement, and the link is in the description below to get an idea of how a reinforcement of a two-way slab is arranged. Alright, so if you don't have time for that, it's also fine. I'll give you a brief description of a two-way slab reinforcement. Alright, so here you can see it's a two-way slab, and the shorter length is 3.883 meters and the longer length is 4.130 meters, right? And we know that the bar that is placed along the shorter span is the main bar, while the bar that is placed along the longer span is the distribution bar. So along the shorter span means parallel to the shorter span, right? So in this case, these two bars are the main bars, while these two bars are the distribution bars, right? Okay, so if we see this bar, you can see that this bar in this slab is here and goes into the other slab, and it goes into the other slab up to a distance of L by 4, and L is of this panel, right? And it gets cranked at a distance of 800, and this is L by 5 from the face of this beam, and L is calculated of this panel. Alright, and it gets cranked and it goes into the beam and gets one turn and returns back into this slab as a top bar. Alright, and the next bar, the adjacent bar, it gets cranked over here at a distance of 800 from the face of the beam and goes into the beam over here, right? So you can see the alternate crank and straight bars, right? So first you place this bar, after this, and after again you place this bar, right? In that way you get alternate crank and straight bar here as well as here, right? So you have to take 50% of the bars into the top to counteract the negative movement that occurs over there. Alright, so same is for the distribution bars as well. Okay, so in a two-way slab, what happens is that main bars are placed at the bottom and the distribution bars are placed at the top, right? You can see this thing over here. Alright, so to calculate the quantity of steel of this panel, what we do is that we first calculate the number of main bars of type A. So let us take this longer bar as the type A, and this shorter bar as the type B, right? So we calculate the number of bars of type A as well as type B separately, and we calculate the length of this bar as well as this bar separately, and we finally find total length of this bar and this bar. And what we do, we multiply the length into a formula which converts the total length into the weight, right? So this is how we do it. Alright, so to calculate the number of bars, so here is a simple formula, right? So for main bars, what we do, so number of bars of type A is equal to total span, that is this total span, this span, right? Not this one. So the length goes along this span, that is shorter span, but they are distributed along the longer span, right? So we take this span as the span to calculate the number of bars. Alright, same goes for the distribution bars. So the length goes along here, but their distribution or the number goes along here. Alright, okay, so the number of bars of type A, total span divided by center to center spacing of bar type A plus 1, and number of bars of type B is equal to total span, this is the same value, and divided by center to center spacing of bar type A, and here we don't do plus 1. Okay, so to verify this formula, I have prepared this simple slab over here, and the total span of this slab is 1000 meters, and the bars are placed at a distance of 100 mm center to center, right? So bar type A, you got bar type B. So bar type A is green in color, while the bar type B is pink in color. Alright, so the center to center spacing of bar type A and another bar type A is 200 mm, right? Okay, so number of bars of type A, that is total span, is 1000 meter divided by 200, center to center spacing of bar type A plus 1 is equal to 6. You can verify this with your calculator, right? If we see this here, we get 1, 2, 3, 4, 5 and 6 number of bar A, right? Similarly, number of bars of type B is equal to total span, that is 1000 mm divided by 200 is equal to 5, right? So we got 1, 2, 3, 4 and 5 bars, right? So here the question can be raised that, so which bar to consider bar A, right? Alright, so the bar that is placed adjacent to the beam is your bar A. So it entirely depends upon the worker. Alright, so he might place this bar here or this bar here. alright. And it must be noted that so the bar that comes here must also come over here as well. So it might sometimes happen that so this bar is here and this bar is here, so in that case you don't have to do +1 over here. Okay, so let's assume that this bar is placed over here, and after that this bar is placed, and finally this bar comes over here, so that we can do +1 for the bar type A. Alright, so same goes for the distribution bars, right? So here let us calculate the number of main bars. So number of bars of type A, that is the longer bar, is equal to 4.130. That is this span 4.130. From the face of this beam up to the face of this beam, plus 1 is equal to 22, right? So number of bars type B is equal to 4.130 divided by 0.2 is equal to 21, right? So now we calculated the bar length. All right, before going into the bar length calculation, we have to calculate this D thing over here. So what is that? I have demonstrated over here. So let us take this bar vertically, that is a section of that slab, right? So if we cut this slab at this position and see in this direction, we will see the structure like this, right? Total length of this slab is L, and the total depth of this slab is capital D. And so to calculate the total length of this bar, what we have to do is we have to calculate the slab span, that is L, minus 2 into clear cover. So clear cover at this position as well as the clear cover at this position, plus 0.42 into D. So we have to add 0.42 into D. Why, I'll tell you later, right? So let us see how we calculate D. So D is the distance from base of this bar, so base of this bar up to the base of this point, base of the bar at this position, right? So to calculate it, what we have to do, we have to so we take D, capital D, minus 2 into clear cover at this position as well as this position, right, minus diameter of this bar. If we do that, we calculate the small d. Alright, so why 0.42 D is that this crank length, this slope length of the bar is 1.42 into D. So how, I'll make a separate video on that topic, right? So I don't want to make this video very long. Alright, okay, so 1.42 into D, this total length is 1.42 into D, this slope length, but we have taken distance from here up to here, so 1D is covered in this L, so remaining is 0.42 into D, and we have to cover for that here. All right, okay, so now what we do is that we calculate D for our slab. All right, okay, so we know that so THK 125 means that thickness of this slab is 125 mm. So what we do, 0.125 minus 2 into clear cover, that is 2 into 0.02 minus 0.008, that is we have used here 85, that is 8 mm bar, so 0.008. So we get 0.077 meter as our answer. All right, so now we calculate the total length of bars of type A. So total length of this bar type. All right, so this we will get by using this formula, right? So number of bars into length of each bar. So if we multiply the length of each bar into the number of bars, we'll get the total length of bars of type A, right? So we know number of bars, right? So we have already calculated it. So now we calculate length of each bar. All right, okay, so length of bar type A is equal to 4.343. So first what you have to do is that you have to calculate the distance from this outer beam up to this outer beam. Right, so if we do it, so what we get from here up to here, right? So it's 4.3. Oh yeah, I have already done that. So it's 4.343 from outer edge of this beam up to the outer edge of this beam. All right, so if we do that, we get the value as 4.343 meter, right? So after that, you have come up to this point, right? Now you have to add this 1 meter value that goes into the other slab, so we add 1, and after that we calculate the part of the bar that goes into this beam. So this is equal to 1 that goes into this slab plus 0.23 that goes into the beam. Here the width of the beam is 0.23. Alright, so you can see that here, so it's 0.23 meter. Alright, so after that what we do, we subtract the clear cover. So you have to supply 1 clear cover for this going bar, right? So at this position, and 1 clear cover for this coming bar at this position, so it's 2 minus 0.02. Alright, so and you have to finally add the value of for the crank, that is 0.42 into the value of D. So if we do this simplification, we will get 6.565 meter as the length of this bar. Alright, so this longer bar. So thus total length of the bars of type A is equal to 22 into 6.565. We get 144.437 meter as our answer. So after that, what we have to do, we have to do the same thing for the bar B. So total length of the bars of type B is equal to number of bars into the length of each bar, right? Very simple. And length of the bar type B is equal to 4.343. That is from the outer edge of this beam up to the outer edge of this beam, plus 0.42 into 0.77, that is for this crank value, minus 0.02, that is clear cover at this position, right? So you don't have any clear cover here because it goes into the beam, and after that there is the slab, so you don't have any clear cover here, but you have got a clear cover here, right? So you subtract one clear cover for it. And if you see these two bars, right, so these two distribution bars, you don't have clear cover for both sides, right? Because it goes into the other slab and you don't have any clear cover here, and same as at this position. So to leave the clear cover or not, it depends entirely on the position of the bar. All right, so we deduct one clear cover and we get the value as 4.355 meter. So thus the total length of bars of type B is equal to 21, that is number of bars, into 4.355 is equal to 91.462 meter. Right, so the total length of the main bar, so we get total length of bar type A, this bar as well as this bar. Now we add these two values, right? So total length of the main bars, that is the total bars that are distributed in this slab, is equal to type A, total length of the bars of type A plus total length of the bars of type B. So 144.437 plus 91.462 meters, right? So if we add these two values, we get our answer as 235.899 meter. So after calculating total length of the bar, now we calculate the quantity of the main bars. All right. So for that we use this simple formula, right? So weight in kg per unit length of a bar is equal to phi square by 162 kg per meter. So it means that total weight of 1 meter bar of certain diameter, that is phi diameter, is given by phi square by 162. For 1 meter bar, the weight is this value. So for x meter, what we do, we just multiply this value with that x meter. So here we calculate total quantity of main bars is equal to this value into the total length, right? So this is for the unit length, and if you multiply with the total length, we get the total kg or the total weight, right? So here we have used the diameter of the bar as 8 mm, so we do 8 square by 162 into 235.899, and if we do, we get the value as 93.195 kg. So in this slab, the total weight of the main bars is 93.195 kg. I hope this concept is clear to you. And now using the same concept, please calculate the quantity of the distribution bars, and so what value you get, please write in the comments below. Okay, so hope this video was helpful. Thank you for watching. Take care.